All right, guys, so a couple quick examples that we want to go through just regarding piecewise functions. So we want to graph each of the following, state the domain using set notation. So what we really want to do here is anytime you're going to do domain and or range, always making a graph always kind of helps that process. It gives you a visual of what x values or y values are actually exist on that graph. And so you always want to graph first, and even if that means sketching like a rough graph, that's fine. So let's go ahead and go through the process of graphing these functions. So first thing I want to do is for x less than or equal to -5. So I want to plot where -5 is, and that's just a rough estimate of where -5 is. This graph is going to follow 3x. So it's going to look like the graph of 3x, which if we just plotted it on its own axis would be relatively steep. It's a line, and it would move on in both directions. So we only want to go up to x -5, and so what we got to do is we got to go way down here to -15. And the reason I'm doing this is because I'm really looking at what is f of -5. That's the highest point in this interval. That's the end point in this interval. We're not going to actually include it, so we want to make sure we include an open dot. But we want to find f of -5. When I plug this in, I get 3 times -5, and that's equal to -15. So I need to plot the point -5, comma, -15 on this graph. So let's go find that. If that's -5, then -15 is probably somewhere down here. We set an open dot on that point, and it's going to look something like this. So we want to make sure that it does look something like that. All right, so there's my graph, and my graph is going to continue on in the negative direction infinitely. And so it looks something like that. It's going to stop at this point. So when it stops at that point, that's when our interval cuts off. And then we jump to this interval. So there's a gap here from -5 to 0 for values that we're not going to plug in. And so we want to make sure that our domain represents that. So we jump up here to 0. 0 is going to be included. So wherever this thing is, we want to make sure that we use a solid dot to fill that in. And we start at 0, so we want to look at f of 0. What's the y value that corresponds to an x value of 0? Well, that's equal to 7 times 0 minus 2. So that's just going to be at -2. So I go over here to 0, -2. That's my point where this thing is going to start. There's 0. -2 is somewhere about right here. Solid dot because of the equality portion of this. And then it's going to increase at a really steep rate. So this thing's going to go really high, really quick. It is a line, so it goes on forever. And so that's what my graph looks like. Let's kind of clean this up, get rid of some of this excess here. So my graph is going to look like that. So the next thing that I need to do is figure out what my domain is. And so again, I'm going to look on this graph. I'm going to look left, and I see that this thing continues on all the way in the left direction. I'm going to look right. This thing continues on in the right direction. But I've got this gap right here, and I need to make sure that that's not included in my domain. So my domain, and I'm going to write this one just for variety's sake in interval notation, using interval notation, are all of the x values in the interval from -infinity up to this point, and not including that point. If we go back up to the original, that point is at -5. So we go to -5 and use an open parenthesis to indicate that we don't want to include that. So that thing stops there. There's the one interval. I want to union that with the next interval, and the next interval picks up at 0, including 0. So square bracket there, all the way to infinity, open bracket. So there's my domain. If I wanted to figure out what the range was, and maybe this is a good exercise just for practice's sake, just for the sake of practice, but I've got this gap in my range where these values, this function will never spit out these values. And so I know that those values are, when I plug this in, this is -2, this is -15, And so my range values are going to go all the way up to infinity, from -2 all the way up to infinity, and not including 15, but everything below 15. So I've got my range values are going to be all the y's from -infinity up to 15, not including 15, -15. And I'm going to union that with this other interval where we start at -2 and go all the way up to infinity. So there's my domain and range for that. The next function, so we're done there. We graphed it, we found the domain, and actually found the range too, and graphed that thing. So the next function we want to look at is this piecewise function where any negative number we plug in is going to follow this rule. So this is going to be 5x plus 1. And any positive value that we plug in is going to follow this rule. It's going to look like the parent function for a quadratic. And notice there is no x equals 0. X cannot equal 0. And so right off the bat, before we even graph this thing, that's the only value that's excluded. So we know that our domain, if we do this in set notation, is going to be in the reals, any x in the reals, such that x isn't 0. All right, so let's go ahead and graph this thing. So up to 0, it follows this particular point. I want to plug in 0, so f of 0 is going to equal 5 times 0 plus 1, so that's 1. So my y value that corresponds with a value of 0 is 1. So 0, 1 is right here. I don't want to include that value, so open dot there. And this thing's going to be relatively steep with a slope of up 5 over 1. So something like that. And that's good enough for our purposes here. The next part of this graph, it's going to skip over 0 and then pick up just after 0. So again, I need to figure out what f of 0 is. But in this particular case, sorry, I should be saying g of 0, because my function is named g of x. But I want to plug in 0 to this thing and figure out where this thing is actually just going to start just beyond. So g of 0 is equal to 0 squared, which is just 0. So I'm going to have a point here. Again, this is going to be an open dot. And then it's going to follow this rule. It's going to look like a quadratic function. So it's going to look something like that. So this is what this piecewise function is going to look like. That's the graph of this piecewise function. And if we want to go write our range, be an overachiever, we can look at this graph and say, all right, well, we're never going to get, this says we're not going to get this value, but if I look over here, I've got a range value at 0. This says we're not going to get this value, but if we look over here, my range value is going to be here. So this actually covers everything. We go from just above 0 all the way up to infinity, from just above, I'm sorry, just below 1 all the way down to negative infinity. So all of those range values are covered. If I want to write that in set notation, it is the y's such that y is a real number. Anything in this particular interval for the y's is going to be in my range. All right, so the next thing that we want to look at are how can we create piecewise functions? We know that absolute values are piecewise functions just by definition, so let's go ahead and write these as piecewise functions. So absolute value essentially tells us that I have two different cases. The first case is I'm looking at the positive version of the argument, and I'm looking at the positive version of the argument when whatever's inside is greater than or equal to 0. So if I need to define my interval, that this function is going to follow this particular rule, I'm going to set that greater than or equal to 0. So 3x minus 5 greater than or equal to 0 gives me x must be greater than or equal to 5/3. So in defining my piecewise function, I've got this 3x minus 5. It follows this rule, and it only follows that rule if x is bigger than or equal to 5/3. The other part of this is the negative version of whatever the argument is. And when does it follow that? Well, we've already solved for this. We've got the greater than or equal to 5/3. So this happens if x is less than 5/3. So a little bit of simplification here. We end up with, we want to distribute the negative. So negative 3x plus 5. And it follows this rule if x is less than 5/3. So writing this piecewise function looks something like this. I've got my two rules. My first rule is it's the positive version, so it's 3x minus 5, and that happens when x is greater than or equal to 5/3. And if I plug in something that is less than 5/3, then I get the negative version, and it's negative 3x plus 5. So example number 2, a little bit more interesting, and it'll simplify to something that's pretty familiar, hopefully for you. But what we want to do is we want to do a little bit of simplification first. So we have this square root function, and underneath the square root function is the argument, x squared plus 12x plus 36. So hopefully you recognize that that thing is factorable, and it factors into something that looks like this. So y equals the square root of x plus 6 squared. Well, I can simplify a little bit farther than that. And anytime you take a square root, the square root is going to undo a power of 2, but anytime you take a square root, you get the positive and the negative version of that thing. Or in other words, that's just the definition of absolute value. So I actually end up the square root of a square is the absolute value of x plus 6, or whatever the argument is. And so I want to write this piecewise function. I know that inside my argument, that's got to be greater than or equal to 0 for the one case. So go ahead and take that. X plus 6 greater than or equal to 0. X better be greater than or equal to negative 6 if I'm going to get the first argument. So let's go ahead and start piecing this thing together. The first piece, it's going to be the positive version, or just x plus 6. And that happens if this case happens, if x is greater than or equal to negative 6. The other one is the negative version. And the negative version looks like negative x plus 6. Distribute the negative, and you get negative x minus 6. So it's going to follow this rule, negative x minus 6, if x is less than negative 6. And there's my piecewise function.